Welcome to the Laboratory, a video series brought to you by Miracles Innovation Labs.
Good morning, everyone. This is Aditya Chini from Miracles Innovation Labs. Today, I'm going to take you through a small demo that we have built at Miracle, which is called a smart parking system using AWS IoT and OpenALPR. So let's move on to the agenda for today. Today's agenda would be smart parking, the application flow, which I'm going to take you through the high level of the application flow that we have built, the technology stack, what are the technologies that have been used for building this demo, AWS Lambda, this is the key thing that we have been using in this, and I'll be going to take you through how that is been working over here. OpenALPR, how that OpenALPR is helping us over here, overview over there. Finally, I'm going to take you through the smart parking architecture, which is a high-level kind of architecture, and then I'll be showing you a live demo on what we have built so far. Okay, let's start. Smart parking, the application flow. So the theme or the main goal of this application is to track, monitor, and assign the parking lots in a parking arena. So we just wanted to track all the cars that are coming into the parking lot, and we just wanted to allocate the slots for the users who are coming into that particular parking arena. So for that reason, we have two ultrasonic sensors which we have placed in and out of the parking arena, where basically it just identifies an object and then takes out an image for that particular car. So whenever the object is near to an ultrasonic sensor, it takes out an image, captures an image, and sends back to the OpenALPR. So we have the OpenALPR API exposed over here. So whenever the image is captured from the Raspberry Pi, it immediately sends the data back to OpenALPR API. So this OpenALPR API helps us to acquire the details of the vehicle based on the vehicle number, which usually have the vehicle number on a number plates. So it acquires that details like what car, what color, what the make model is, manufacturing, all those kind of details will be coming out in a JSON object, and that is being publishing through the Raspberry Pi gateway through an AWS IoT platform. So we have been using AWS IoT platform here, where we're tracking all the messages that has been published from the Raspberry Pi. So once the car enters into the parking arena, we have been assigning the slots based on the based on the available slots. Based on the available slots, we were doing that slot occupancy for the user as well. So out of this smart solution, which is really help us for monitoring, track, and record the number of cars entering and leaving the parking lot. So we have a rich dashboard built with AngularJS. So we will be showing that dashboard as well. So we have the live data coming in, and all the metrics have been shown in form of charts and pie charts and graphs. So you can usually visualize how many cars are coming in today or tomorrow or last week, how many cars are there, how many repeated cars are there. So all those tracks, all those analytics have been tracked and captured and been put in a nice form of insights on the dashboard as well. So technology stack. We've been using AWS IoT, Python, Node.js, and OpenALPR. So AWS IoT, we securely connect 1 billion devices to the AWS platform. So what are we doing over here is we have our AWS IoT platform, which has been continuously taking in the messages from the Raspberry Pi, which I earlier said that the RPi or the Raspberry Pi is setting out the JSON object which is coming out from the OpenALPR. So all those things are published back to the AWS IoT from the Python server. So Python over here is used on the Raspberry Pi. So the server that is actually handling and publishing these messages to AWS IoT is Python. And Node.js we've been used for building an entire dashboard. So Angular and Node has been used for connecting back to our backend system and getting the values and displaying on the dashboard. So that's all we are doing with Node and Angular. OpenALPR is a new license plate recognizing API which is being developed. It's again a Python library, so it has various APIs like various countries. They have the APIs for various countries. So recently they have launched for India as well. So we've been using that for recognizing the number plates to get the number from that. AWS Lambda. So as I earlier said, this is a key role that's playing in. So reason for using AWS Lambda in our solution, so it's a stateless event-driven compute code which is called as Lambda functions. So you don't need to manage or spin up your instances in order to deploy your applications. So you just need to write a piece of code or a function which is required to do that particular action, and then push back to the AWS Lambda server. So what they exactly do is it's going to trigger based on whenever you require that particular function to be spin up or to execute. So that at that area it's going to start executing your function. So it also helps to trigger various AWS services also. So whenever you wanted to trigger from another AWS, let us suppose, say for example, we have an AWS IoT. So whenever you have a published message, you can do a trigger to the AWS Lambda and do whatever you want in that particular function. So that's how we usually do triggers from other services as well. And so AWS Lambda itself can handle, it can do the auto scaling, capacity, fault tolerance, logging and monitoring. So all those things is also been handled from the AWS Lambda itself. And then the beauty of it is you only pay for what the request that you have been using for that. So only it has like some free requests that you can use and play, but whenever you go into production, you have 1,000 requests as you go and pay for that only. So on the right hand side, you see a small flow diagram which has been showing it. AWS IoT is setting it to IoT rule. So I'll be explaining that what IoT rule been using in that in the next slide, that is the architecture. So I'll be telling you what that exactly mean over here. So concentrate on the AWS Lambda and the API gateway over here. So all the functions that are going and fetching the data from the database over here is actually being written in an AWS Lambda functions. So it goes and checks for the DB, and then that data has been exposed to an API from the API gateway. So we are publishing APIs from API gateway as well, and these APIs have been exposed, and we were able to consume that from our web application as well. So that's about Lambda over here. So OpenALPR, I'm just going to take it at a very high level. So what OpenALPR is? So it's like open source automatic license plate recognition, as I earlier mentioned in the previous slides. So we have a REST API which has been exposed from the OpenALPR platform, which usually takes in the image of the car or of the bike, whatever the thing that has a license plate, plate with a number. So whenever we capture the image and send back to the API, it actually acquires the data from that particular API and gives you the JSON information which is there on the slide. So you can see the number plate, what the number is, what the color of the car, what the vehicle type, and engine number. All those kind of metrics has been giving out from the API, which has been helping us to build a demo over here. Okay, let's move on to the architecture. So this is a kind of high-level architecture that we have built for the demo. So if you can see on the left-hand side, we have a car image which is trying to come into the parking area. So whenever the car is trying to come into the parking area, we have the ultrasonic sensor over here, which is continuously monitoring the range. So whenever the car comes and falls into the ultrasonic range, it invokes the ALPR camera from the Raspberry Pi and takes a snap for that. So it just clicks an image for that, and just that image is sent from the Raspberry Pi to the OpenALPR, which is a REST API that we have. I already said that. So it just takes whether it's a car or maybe some other object came in the middle. So whenever it identifies if it's a car, then only it will be publishing that particular object or that particular payload to the AWS IoT platform. So once we have the data coming in the AWS IoT platform, we have the AWS IoT rule invoked over here. So let me explain about the AWS IoT rule over here, as I mentioned earlier. So AWS IoT rule is nothing but we just had written a rule over here which states that whenever the payload or the message coming out from the Raspberry Pi, it just invokes a Lambda function. So that was the rule that we wrote in the AWS platform. So whenever there is a message coming in to the AWS IoT, it just calls the AWS Lambda. So that's the reason why we used AWS IoT rule over here. So let us say once we get the message over here, say the car came in, and we just wanted to check that car is already there in the parking lot or not. So that car number is being sent to the database, and we just check all the records and see whether the car is there in the database or not. So suppose if the car is not there, and then we just quickly assign a in timestamp to the car, and when we insert that particular record into the car into the database. Let us say if we have the car inside the parking lot, and we don't have the out timestamp, which will be null while the car is being going into the parking lot. So whenever the car is trying to come out, we just update the same document without timestamp as well, and we remove that particular slot and we make it empty for the other cars coming into the parking area. That was the logic that we have built in the backend system, and so AWS is being, the service is being exposed through the API gateway, which is being accessed from our web applications over here. So this is the kind of high-level architecture that we have. So I'll be doing a quick live demo for you guys. So I'll be showing you what the dashboard is and how the data has been flowing in from the backend systems over here. Okay, so let's move on to the demo right now. So if you can see my screen, so we have our smart car parking system dashboard, which we have built on AngularJS. So you can see the dashboard is with 4 categories of slots. You have handicap, prime, plugin, and general. So and you have the available slots and occupied slots. So we have some data which is already incorporated. So you can see those metrics over here. So handicap, we already have 2 occupied, and remaining are 3 categories that we will be doing a small demo where we will be getting some data into the general parking lot. So I'll be showing off that in a while. So if you can see over here, as earlier said in the presentation, so we have some insights being developed. So if you can see, we have a donut chart where it will be showing all the available slots and the fill slots. So you can see right now we only have 2 fill slots, which are the handicap ones, and the available are 38 for all the categories that we have above. And the vehicle analysis, like what type of car is that? So whether it's a sedan or SUV. So right now the data which is there in the backend system, so we have 89% of sedan cars and only 11% of SUV. And we do have vehicle statistics. So the statistics over here is we are trying to showcase how many unique cars are coming into our parking arena and how many return cars, which are like the cars coming in frequently into the parking arena. So we've been tracking that as well. So if you can see, this is all the historic data that we have in our systems. And today is Friday, so we have some cars in the parking arena for now. So you can see 2 return cars and 2 unique cars over here. So the occupied slots, this is purely based on the timings. So right now, based on the time, we have 3 cars in the database for today. This is all based on time. So we have all the occupied slots over here in form of graph as well. So this is overall the dashboard that we have built, and if you can see on the left side menu, we have levels as well. So these levels will be indicating how many cars are there occupied and how many slots are available for now. As we saw in the dashboard, we have 2 handicap slots already occupied. So those are turned into gray color, and the rest are all in blue color, which means they are already available for next cars that are coming into the arena. So if you can see the parking logs, so this is where we are showcasing all the historic data that we have in the system. So we are mainly concentrating on the vehicle model and what the color of the vehicle, vehicle number, in time and out time, and slot allocated as well. So if you can see, we do already have 2 slots, which is our handicap slots already allocated, and you can see the out time as well. So the data model that we designed over here is we don't be having out time when the car is coming in. We only put the in timestamp and we just insert the document over there. So that is again with the other car as well. So once we try to pop out the car from the parking lot, so then the out timestamp is updated into the document, and then we showcase that as well. So you can also see the historic data. So like if you want to see yesterday's or last 7 days, you have all the data metrics that are coming out from the database for now. So this is all the historic data that we have. And this is all about the last 7 days, and you can just navigate the pages over here as well if you want to see the old data. So this is all about the dashboard that we have built. Okay, let us see a quick operations of the cars coming in and coming out. So I will be opening my Raspberry Pi server. So I'm going to have a Python server running right now. So I'll do that. So I have my server, which is actually taking the image and then sending it to AWS IoT platform. Yeah, so the image is captured, and we are sending the car image. So you can see all the data coming out from the Open ALPR, and successfully published to the AWS platform as well. And now let's get back to the dashboard and see the levels. It will be see. So now we have slot 3 got assigned to the car, which just came into the parking arena, and then that got disabled. So that way it indicates that it got occupied. So let us go back to the dashboard and see. So you have the general parking lot. So we used to have 10 available slots, and now we have 1 occupied. and the available slots are 9 for now. And you can see the slots filled are 3. Previously it is 2 and now it's 3. So this is all the real-time data that we are listening from the AWS IoT, and then capturing the data and putting in the form of analytics over here. And that's how we are doing over there. And you can see the fourth car coming in with a time just now, and you can also see the vehicle statistics. So we have written car, so we have a third car coming in over here, and you can see in the parking logs as well. Yeah, you can see the slot 3 as well. So yeah, here is that the slot 3 is also null, so we don't have the out stamp time, because the reason being the car is just came into the parking arena with the in time stamp. So now we're just trying to bring out the cars. So we're just trying to pop out the cars from the parking lot, so that way we'll get the slots again available for the remaining cars coming into the arena. So in the meanwhile, while the data get replicated back to that dashboard, let me show the components that we have. So you can see my Raspberry Pi over here, and an ultrasonic attached to an ALPR camera, which is actually taking the car image. You can see, which is a car image that is taking on, and that's been sending back to AWS IoT platform and OpenALPR for getting the JSON object that we saw earlier. So now we can see we popped out one car, and let us go back to the levels and see. So yeah, so slot 3, before we used to have slot 3 got disabled, and now slot 3 got enabled, so that that is available for other cars coming into the lot. So let's just go back to the dashboard and see. So yeah, so if you can see in general, so you have now the occupied slots are 0. So because one car which came into the lot just turned out of the parking arena, so that it got updated, and the available slots are 10. So if you can see in the parking logs as well, so they will be yeah. So here is the updated time. So this is the out timestamp when the car moved out from the car parking area. So this is how we are tracking the dashboard. So how we are maintaining levels and the parking logs. So that's where like we've been using Lambda and OpenALPR and AWS IoT for just maintaining this lively. And this is how the dashboard is being tracked. All the logs and insights are being tracked and put over in the dashboard to make it a better view. So this is what we have been built with smart car parking system. Yeah, thank you.
Thank you for watching The Laboratory, a video series brought to you by Miracles Innovation Labs. For more on innovation, please visit miraclesoft.com/thelabs.